Hello friends, let's now try to analyze merge sort or try to find the time complexity of merge sort. So as we know, merge sort is a recursive algorithm, so we'll be writing the recurrence for merge sort and we'll be trying to solve that recurrence by using the method of repeated substitution. So here is the recurrence for merge sort. T of n is equal to time taken by merge sort for the input of size n is equal to time taken to sort the left half, which is of size n by 2, plus time taken to sort the right half, which is also of size n by 2, plus time needed to merge the left half and the right half, which if we compute, it is exactly or roughly equal to n. That means in order to merge this array of size n by 2 with the other array of size n by 2, we'll roughly do n comparisons, right? So if you remember, so merge sort will be given this array A, let's say. So what we do in merge sort is we compute the left half, compute the center, or we find the center and say this is my left half from L to mid and this is my right half from mid plus 1 to R. That means I am doing the division of this array A exactly half. That means if originally I have n elements, left half will contain n by 2, the right half will contain remaining n by 2 elements. So thus we write the recurrence. Time needed to sort this array of size n is equal to time needed to sort this left half plus time needed to sort this right half, plus once I get the left half sorted and right half sorted, I'll need the time to merge these two, left half and right half, in order to get the entire array sorted. So that time will be roughly equal to n if we do this computation. That's how I get the recurrence. So if I rewrite this recurrence, it will be twice t of n by 2 plus n. So t of n is equal to twice t of n by 2 plus 1 n. So this is equation 1 and this is the recurrence for merge sort. So now let's try to solve this by using method of repeated substitution. Solving recurrence means getting rid of this t on the right hand side. So now I don't know what is this t of n by 2, but I'll derive t of n by 2 from equation number 1 itself or from the same equation. So substitute n by 2 in place of n in equation 1. So equation 1 becomes t of n by 2, we are substituting n by 2 everywhere in place of n. N by 2 is equal to twice t of n by 2 is n by 4 plus n by 2. So that's equation 2. Now substitute equation 2 in equation 1. So we are substituting back this equation 2, that is this equation in entirety, in place of this t of n by 2 here. We are substituting this value of t of n by 2 here. So equation 1 becomes t of n is equal to twice, we are substituting this entire thing in place of this. So we'll do it in substitute in bracket 2t of n by 4 plus n by 2. So that value of t of n by 2 plus this n. So if I solve this, I'll multiply inside this. 2 into 2 is 4, but I'll write 2 square, this t of n upon 2 square plus 2 and 2 will get cancelled. So I have 1 n here and this n here, 2n t of n. This is equation 3. But still I have this t of n by 4 term here, whose answer I don't know, but I'll get the answer of t of n by 4 again from equation number 1 by substituting n by 4 in place of n everywhere. So substitute n by 4 in place of n in equation 1. So therefore equation 1 becomes, so t of n by 4, I am substituting n by 4 in place of n everywhere, twice t of n by 2 by 4 is n by 8 plus n by 4. So that will be equation 4, let's say, and substitute this equation 4 back in equation 3. So equation 3 becomes t of n is equal to 2 square. So I'm substituting in place of this value, right? So twice t of n by 8 plus n by 4 plus this 2n. That's what equation. If I now rewrite this equation here, so I'll have t of n is equal to 2 square will multiplied in this bracket. So 2 square into 2 is 2 cube. Inside then I'll have t of n upon 2 cube. So plus 4 and this 4 will get cancelled, and this n will be added to this 2n, so I'll have 3n. Right. So now still I have this t of n by 8 term. I want to get rid of this, but I don't know what is the answer to this. So I'll again try to derive the answer of t of n by 8 from equation number 1. And if you do that substitution and whatever value you get, and if you back substitute that value in this equation, you will get the next equation, which will look like this: 2 raised to 4 t of n upon 2 raised to 4 plus 4n. Right? If you do one more step, right, so you will get t of n equal to 2 raised to 5 t of n upon 2 raised to 5 plus 5n. And likewise, if you continue and if you try to derive the pattern here, the pattern is like this: 4 4 4 3 3 3 2 2 2, right? That means in general I'll have t of n equal to 2 raised to I, let's say in ith term, ith step, 2 raised to I into t of n upon 2 raised to I plus in, right? So this pattern will get, this equation will get, but I'll still not be able to get rid of this t term. So how will I get rid of this t term? So I don't know what is t of n by 2, t of n by 4, t of n by 16, t of n by 13. That I don't know, but I certainly know that is t of 1 is equal to 1. Time needed to sort one element is equal to 1. That I know. So that means when the term inside this bracket becomes 1, I will have t of 1 here. So and I know the answer that time, t of 1 is 1. But will this term become 1? Certainly it will become 1, because we are every time dividing the input by 2. That means every time our input is getting half, right? So if we start with n equal to, let's say for example 100, and in the next step that 100 will become 50, then it will become 25, so on and so forth. Ultimately the term here will become 1. So let us say we have reached there and the term inside the bracket has become 1. Let we have reached there, or we have n upon 2 raised to I is equal to 1. So if I simplify this, n will be 2 raised to I, and now if we try to find the value of I, so I that can be done by applying log to the base 2 on both hand sides. So log to the base 2 of n, log of n to the base 2 is equal to log of 2 raised to I to the base 2. So which is equal to, this I will come down, I log to the base 2, but I log to the base 2 is, so log 2 to the base 2 is 1, so this will be I. So the value of I is log n to the base 2, and this is one more thing which will require. So now if I substitute back these two values in this equation will be t of n is equal to 2 raised to I, we have the answer to this 2 raised to I here, and t of this term has become 1. We have assumed n upon 2 raised to I is equal to 1, plus I is log n to the base 2, and this n I'll write here. Now this has become 1, so the answer will be n plus n log n to the base 2 t of n, and this is the solution to the recurrence of merge sort. In fact, this is the time complexity of merge sort, which is big O of n log n to the base 2. So thanks for watching.